Okay, so this is the difference between similarity and congruency. No, not done yet. Okay, those who are done copying, look at the next diagram. They say ABCD is similar to PQRS. Quadrilateral similar to another quadrilateral. Just by looking at the diagrams, do they look similar to you? Do they appear to be an enlargement? One of it is an enlargement of the other. Yeah, to my eyes they look like the same. But I cannot be sure until I look at all the angles. So look at angles, 60 and 60, okay. 140, 140. Oh, but in this question they tell you that they are similar. So since they tell you that they are similar, we know that all the corresponding angles are the same. So this must be 80, this must be 70. Then because I know there is a property of the sum of angles in this polygon, I would like to do a quick check. 80 plus 60, 140, 280. $280 plus 70, 350. $350. Is there something wrong? Yeah, something is wrong, obviously. It cannot be equal to 350 only, right? What must it be equal to? It must be equal to 360. So I would like you to make an adjustment. Let's change this to 80. Otherwise, the question is wrong. But 80, there you appear 2 times. Okay, let me choose something else to change. Let's change this to 150. Change this to 150. Okay, now the question makes sense. You understand what I'm doing? Then do we have the same problem in congruency? Okay, it doesn't affect anything, but just know that it cannot be possible. This shape cannot be possible unless the sum will be is given to be 360. So back to similarity. Now we're going to use the same idea, same approach to write out all the corresponding angles and all the corresponding sides. BAD, QPS. Help me check if I made any mistakes. PQR, BCD, QRS, CDA, RSP. Okay, are my answers correct in the first 2 tables? Then what about the last table? What have you noticed about the ratios of the corresponding sides? They're all 3/2. Highlight this, corresponding sides. It is not any sides when divided by each other will give you the same value. Must be corresponding side. Okay, just like our PQ and AB, PQ and AB. QR and BC, QR and BC, and you get the idea. Then I want you to realize also for the ratio of corresponding side, what is in the numerator? They are the sides from which triangle? The bigger or the smaller triangle? Bigger or smaller? Numerator. All these numerators, they are from the bigger triangle. Then the denominators, they are all from the smaller triangle, right? What happens if I do it the other way around? What if I put smaller triangle as the numerator, bigger triangle as the denominator? What will my ratios, what will my fractions be? 2 over 3. Is it the same for every one of them? Yes. So doesn't matter which one you choose as numerator, which one as denominator. As long as you're consistent, you will see that the ratio is the same. Okay. So in similar figures, corresponding angles are equal. Corresponding sides are proportional. They have the same ratio. Proportional. Yeah, I just want to really emphasize this one. They must be the corresponding sides. Right, next. This is the summary in mathematical terms. We say that all the corresponding angles are equal, and this is the next one, which is telling us about the ratio. AB over XY. So we have AB over XY. Next, BC over YZ. And the last one, AC over XZ. All the ratios are the same. Okay, so to prove that two quadrilaterals are equal, to prove that two shapes are similar, what must I do in order to show that two shapes are similar? Find the ratio. Yeah, we can find the ratio. We can prove that this is correct. We can either prove that number 2 is correct, or number 1, property number 1 is correct. Either this or this. Let's take a look. These two quadrilaterals are shown. Your job is to prove that they are similar. Do you want to compare angles and say that all angles are the same, therefore they are similar? Or do you want to use ratio of sides? Ratio of sides, why? Yeah, of course no angle is given to you. You have no choice. Do you need to prove just two sides or all the sides? All. Yes, you must prove all the sides. So let us begin. Which side would you like to start with? AB. Okay. So AB, I suppose you want it in the numerator lah. Okay. So divided by PS. Okay, let's find out what this is. 6 divided by 4.5. That is 4 over 3. Okay? So let's do it systematically. Don't just jump all over the place. What happens after AB? What do you want to do next? Okay, BC over SR. 8 over 6 equals to 4 over 3. So far, so good. Seems like they might be equal after all. Next, I suppose you want CD divided by RQ. 7.2 divided by 5.4. Can you do it mentally? Not so easy, right? But what are we hoping to be the answer? 4 over 3 also. Okay. So 7.2 divided by 5.4. 4 over 3. Yeah, we are right. And the last one, DA over QP. So 4 over 3 again. 4 over 3. Okay, then how do I present my final statement? I have shown that all of that is 4 over 3, right? So right now, since AB over PS equals BC over SR equals CD over RQ equals DA over QP, which is 4 over 3, then the quadrilateral ABCD is similar to SRQ. Wow, very tricky, this question. Is it tricky? Hai Jie, what is ABCD similar to? ABCD, now that we have proven the ratio of sides, they're all the same. PSR, can I write PQRS? Because ABCD ma, so PQRS. Can or cannot? Okay, so what is the answer supposed to be? P? SRQ, okay, correct. So the naming is important. Example 2, identify if the two figures are similar. Now your turn to try it by yourself. In the first place, right, since I am not sure whether they are similar, then do I have corresponding sides? If I'm not sure whether they are similar or not, can I for sure tell what are the corresponding sides? You get my question? Because corresponding sides are applicable only for congruent and similar figures. In this case, they might not be similar after all. What if they are similar then? If they are similar, can you tell where the corresponding sides are? How? Now I'm assuming they are similar. Then what are the corresponding sides? I saw everybody chose 6 and 9 as the corresponding side. You chose 4 and 8 as corresponding side. You chose 3 and 6 as the corresponding side. Didn't you? That's what you did. Yeah, but why will you choose them to be the corresponding sides? You get my question? So this is how you convince me that your choice makes sense. Because you are right to use those ratios. But you need to convince me. And this is how you should convince me. I will compare longest with longest. Make sense? If they are similar, then the longer side must correspond to the longer side. I will compare the shortest with the shortest. I will compare the remaining with the remaining. If they are similar, then these must be the corresponding sides. So with that, let me find the ratio. PQ over XY. 6 over 9 equals to 2 over 3. Then I try the next one. QR equals, over YZ equals to 4 over 8 equals to half, which is not equal to PQ over XY. Should I carry on? Should I find the last ratio? Should I? Is there a need to? No need already. As long as I have ratios that are not the same, then it's not similar anymore. I don't want to waste time already. So since PQ over XY not equal to QR over YZ, triangle PQR not similar to triangle XYZ. If you continue to find a third ratio, you will not be faulted. It's just not essential. It is not essential for you to find a third ratio. Now that you have a pair that are not equal. Okay? So if you chose to do it this way, QR, suppose you start with QR over YZ equals to 4 over 8 equals to half. Then you chose PR over XZ equals to 3 over 6 equals to half. Do you need to carry on to find the third one? If you did it this way, you chose these two sides first. Do you need to find the third side? Yes, you need to, because you must prove that all are the same to prove that they are similar, or you need to show that at least one is different, then they are not similar. So you must go on. That will be PQ over XY equals to 6 over 9, which is 2 over 3. So since PQ over XY not equal to, you can choose either one of these, QR over YZ if you like. Then you have the same conclusion. Okay? Okay, don't have this angle over here given, but what is given is 6 and no 2.5. This is 2.5 and this is 7.5. Okay. So our homework is up to page 5. By the next lesson, I see you.